A bit of alkaline corrosion to clean up on the front of the board, and a bit of corrosion on the back of the board to clean up also. So here is the special solenoid circuit for Q85, which is not operating correctly on this System 9 board. And you can see the switch comes in at J18 pin 9, and then it's supposed to be pulled high by this pull-up resistor, 4.7K, and it's a SIP resistor located at SR21. And then the signal is NORD, that's not OR, at U6, with a low signal, generally from, should be from the blanking circuit. Sorry, I went the wrong way. Yeah, it's down here in the blanking circuit. So let's do some probing. U6 pins 8 and 9 should NOR to 10. So here is U6. Pin 8 is low. Pin 9 is low. And pin 10. Now, NORing that should be a, let's see, if you OR 0 and 0, you get 0, and not that is a 1, so this pin should be high. But another thing that's odd, as we recall, pin 9 should be pulled up by SR21 pin 7. And here is pin 9, and it is not pulled up. So here's SR21 pins. Let's just do 2, for instance. This is the pull-up resistor. 2, 3, 4, 5, 6, 7 is low. So either this SIP resistor network, which is called a bust resistor, since this is 5 volts and the rest of these pins go out to devices, either this is not doing its job, or this 7402 at U6 is gone hinky. There is no way to find out easily. You could cut a trace. I don't do that. I'm going to bet on U6 being faulty because I have seen this so many times where a failed special solenoid will backfeed up through the drive transistor, the pre-drive, and then eventually hit U6. So this transistor has already been replaced by the client, and I will be right back. Now, one thing I can do before I remove U6 is diode test it. So I have my meter set to diode check. I use a Fluke 179. You don't need one that fancy, but that's the one I like. So I have my red probe connected to ground right there. And ground is also pin 7, so we can show that is shorted. So you can diode test all the legs of, sorry about that glare, of the chip, and they should read about like these are reading. Now these aren't the really interesting legs, but I'm just doing those for baseline. Now that's an unusual reading. That's between pin 7 and pin 14, and that's what I call the residual. Alexa, stop! Crazy device. This is what I call the residual diode check from 5 volts to ground. So I'm going to move down these pins. Now this is the affected pin, so you can see that is clearly shorted, as is pin 9. So the only one that's good is pin 8. So this chip is going to come out. And here we have a System 9 Space Shuttle MPU, the game that saved pinball, as is alleged, and I don't doubt that in the least. This one had some issues in the special solenoid section. You can see there's a little bit of a burn mark there from when Q85 decided to roast itself. Now that's going to drive a pop bumper or a slingshot, so when the client gets this board back, I need to remind him to address that situation, or it will simply blow that transistor again. In this case, there was some feedback, and it also destroyed U6, as I showed in the video that I threaded in before this one. I also replaced one of the tip 102s that somebody had scavenged out of the Q57 position, probably to put up in a special solenoid section. Nothing wrong with that, because on Space Shuttle, Q57 doesn't do anything. The board was sent to me without the auxiliary soundboard, but I have doctored my firepower soundboard by jumpering it so that it would accept 2732 ROMs, and so we can listen to some sound. I have installed NVRAM, replaced every cap on the board. This is in the reset section, 3 power caps, and then there's 2 over here in the sound section. 3, I'm sorry, in the sound section. And we should be good to go. Oh, the last thing is, System 9 boards come with the craptastic round header pins, like all System 3 through 7s. So I have removed all the headers all the way around and replaced them with some quality ramp lock square pin connectors. Let's boot it up. Victor's test display also supports System 9, so you can see that operating correctly. And here is lamp matrix, and the only solenoid that's on is solenoid 16. Let me dim the lights a little here to make this a little better. And the first thing we're going to do is enter display test. And that is working properly. Both the ball and play and credit display is operating properly. And all sounds being produced correctly. All 64 lamps in the lamp matrix operating correctly. And now we are on to the solenoid test. The red LEDs are the first 8 solenoids. System 9 did not multiplex the solenoids at all, so we'll see all 16 of these being driven. And System 9 also does not drive the special solenoids directly, but I have a simulated switch input to show that all of those are working. These 2 bright orange lights are the flipper power enable relay. And the next test is switch test. And let me see if I have it up here. Space Shuttle. The last switch is switch 49. So let's go through the switches. "46, 48, 49. Excellent. And that is it. I have placed this game on free play. At least I think I did. Maybe I didn't. I did not. So let's advance setting 30 to 0. And now we are on free play. And setting 18 from 30 to 0. Sorry about that. And since we have NVRAM installed, this board will arrive at the customer's house on free play, plug and play, except please do look into what transistor or what coil is driven by Q85 and make sure that that is not shorted, including the diode on the coil, and make sure that the wiring to the coil is wired correctly. With the smaller of the 2 wires will be on the non-banded side of the diode. Thank you so much.